Let's look at one more example of graphing quadratic functions. I want to start by looking at the leading coefficient. Since it is 1 and not negative, that tells me that the graph is going to open up, and there's also going to be no stretch or compression because the leading coefficient is just a 1. So that tells me when I graph it, I will go from the vertex over 1 and up 1, over 2 and up 4, over 3 and up 9. Let's go ahead and look at what the line of symmetry and the vertex will be. The line of symmetry we find by using the formula x equals opposite b over 2a. So the opposite of b in this problem will be negative 1 over 2 times a, which is positive 1. So the line of symmetry is x equals negative 1/2. And we use that line of symmetry to find the vertex. So the vertex will be at negative 1/2 for the x-coordinate, and then we've got to sub in negative 1/2 to the original equation. So I'm going to be doing negative 1/2 squared plus negative 1/2 minus 2. So my y value will be negative 1/2 squared plus negative 1/2 minus 2. Negative 1/2 squared will be negative 1 times negative 1, which is 1, over 2 times 2, which is 4. So that's positive 1/4, plus negative 1/2, and then minus 2. And since we're dealing with fractions, we need a common denominator. So we have 1/4 plus negative 2/4, and then minus 8/4 will be 1 plus negative 2 is negative 1/4, and then minus 8/4 will be negative 9/4. So we have 1/2 negative 9/4. Excuse me, negative 1/2. So negative 1/2, we go negative 1/2, and then 9/4. Here we have 4/4, 8/4, 9/4. It's right there. Okay, let's look at our intercepts. How about the y-intercept? And then we'll look at the x-intercepts. The y-intercept for a parabola in standard form will be at 0c. So in this problem, it's at 0, negative 2. So we're going to put that on our graph. 0, negative 2. And then the x-intercepts remember we set the equation equal to 0, and we could solve that by factoring, quadratic formula, or completing the square. I think I can see a way to factor this, so it would be x and x, and it has to be 1 and 2. The signs will be different, and I'm trying to get positive x in the middle, so I need my 2 to be positive and my 1 to be negative. So that gives me x squared minus x plus 2x, and then minus 2. Yeah, that works. So I set x minus 1 equal to 0. Add 1, I get x equals 1. I set x plus 2 equal to 0. Minus 2, I get x equals negative 2. So my x-intercepts will be at 1, 0, and negative 2, 0. So I can go ahead and put those on the graph as well. At 1, 0, and negative 2, 0. Now I don't have enough ordered pairs on here to get an accurate graph, but I also have that pattern that we talked about at the beginning. So I can go from my vertex and just approximately over 1, up 1, over 1, up 1, and then go back to the vertex, go over 2, up 1, 2, 3, 4, over 2, up 1, 2, 3, 4, and I can go over 3 and up 9. 1, 2, 3, up 1, 2, 3, 4, 5, 6, 7, 8, 9. And over 1, 2, 3, up 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, that is going to give me a very accurate sketch for my parabola. So we'll connect those with a smooth curve. And then we can use our graph to answer some questions, like the domain and range. See, the domain is easy to answer for any parabola. It's always negative infinity to infinity. The range, however, changes. So the range, we're going to go from the bottom of the graph to the top, and we're listing all the y values. So the graph does not start down at negative infinity. There's no graph until we hit this y value right here, which happens to be the y value of the vertex. And since the vertex was at negative 1/2, negative 9/4, the range is going to start from negative 9/4, and then the graph continues all the way through infinity. So negative 9/4 to infinity. And in fact, we can look right now and tell that the graph is going to have a minimum. So this function has a minimum. Because it's got kind of that rock bottom value right here. And the minimum value actually is the y value of the vertex, and we can get that from either the vertex or the range. You can kind of tell that it has a minimum because it goes from negative 9/4 all the way through infinity. So the minimum value is negative 9/4. Let's look at where this graph is increasing and decreasing and positive and negative. Remember that increasing and decreasing has to do with where the graph is going uphill and downhill. So increasing is going uphill and decreasing is going downhill. So as we go from left to right, from negative infinity over to positive infinity, if I'm tracking this graph left to right, right now the graph is decreasing, 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 decreasing until right here. At this x value right here, the graph starts increasing, 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 increasing. So as you're going left to right, the graph is decreasing for all the x values between negative infinity and this one right here, which is negative 1/2. So it's decreasing negative infinity to negative 1/2. And then at that vertex, at that x value, it starts to increase, and it increases for the rest of the time. So it's increasing from negative 1/2 to infinity. Now, positive and negative means where's the graph above the x-axis and where's the graph below the x-axis. So if we cover up part of our graph here, we can see that the graph is positive or above the x-axis everywhere between negative infinity and this value right here, which is our x-intercept at negative 2. And then the graph is positive again or above the x-axis at this x-intercept 1 all the rest of the time to infinity. So it is positive between negative infinity and negative 2, and then it skips over and it's positive again from 1 to infinity. But the graph is negative or below the x-axis just in this little section between negative 2 and 1. It dips below the x-axis, so it's negative between negative 2 and 1.